So today we're going to talk about Go channels, S3 love story. It's going to be a hands-on workshop, so prepare to write a bit of code. And the goal is to be able to have high concurrency and throughput S3 operation using Go. Okay, setup. So you can scan it or go to this link and follow the instructions. There is README there. First, install Go. See that you have a working Go. And then install vscode and see that you have Copilot installed, integrated, logged in, and you have the Go extension enabled, and you can run the main Go. It's in the README file. So open the repo.
Account, AWS?
No.
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 We can always make it for workspace on it.
Yes. Whoever finished, raise his hand. Good. Barrel is number one. Okay. So I'm continuing after the setup. Now a bit about the differences between running locally or on your own data center versus running on the cloud. So there is a paradigm shift. The paradigm shift is that we used to think, this is me, that the CPU is the fastest, right? Below it, the RAM. The RAM can process very, very fast operations. If you do only in-memory operations, usually your program will be fast enough for our needs. And below it, you add a persistent disk, which can go to up to 3.5 GB a second on SSDs, and below it, the network, which can be 1 GB, maybe if the other side allow it, and it's not that stable. So how we used to process data is to get a lot of data locally to the local disk, and then work on those files, generate different files, and then upload them with retries to some external destination. But when we work on cloud compute, the disk and network switched. Here you see it's written network, right? It's not disk, it's network. That's a typo. So the network for the cloud, it's you have 10 GB for bursts for smaller instances, and you have 20 GB a baseline for larger instances. The meaning of this is that if you run with a medium-sized instance, it costs like this $1 an hour, but you can process in 1 minute 600 GB of information. That's a lot of information. This is if you don't touch the disk and you have no CPU and RAM utilization problem, right? If you only stream pure data. So the actual will be lower, but even 200 GB a minute, that's a lot of throughput that you can utilize. And it's meaning that if you run this instance for 24 hours, it costs you $25. We're not talking about S3 usage cost and all the extras, right? Only the actual compute. It costs you $24 to run for 24 hours, and you can process 840 terabytes of data, which is a huge amount of data. We will never have, hopefully, this amount of data. If you go the other route of writing to disk, if you run on medium-sized data sets, it's still okay. You can run in 24 hours, you can process 10 terabytes of data. Usually, that's enough, okay? It's much easier to work with disk and not on streaming, because then you have checkpoints on your way that you can open and see. So you need to do your own consideration and try not to optimize. If disk is enough, write to disk, use the common tools, use the CLI tools, Unix pipe, sed, grep, they're great to generate a lot of small local files, and then you can work on them and upload them, okay? Not always you need to do streaming. And here is a nice website from Vantage, which gives you a list of all the EC2s, and you can filter them there by memory size or network throughput. and you can see their monthly or hourly rate. So this is how it looks. I needed to manually process the access logs of several months. It was more than 100 million small files, which I wanted to aggregate and also sort. So here you see it ran for about an hour and a half, and it stopped. And it cost us less than $5 to run. And doing the same in Spark or any other framework would at the end cost much more. A, on working hours, because you need to build something that can run distributed, and B, because you will have a lot of network going there. You will have many small instances that talk to each other. And in this case, I started a small instance. I copy all of the files locally using what we will just see. And once it was locally, I stopped the instance. I increased its size to a machine with 500 gigabytes of memory and 64 cores, ran the second script, which ran for an hour and a half, and it automatically shut down at the end. And that's it, I finished, okay? So this is a good usage, it both on cost perspective and on developer side perspective, because it didn't take me long time to write the code that does it, okay? So in the cloud, you have power, so use it. Follow up. Regarding computation on the CPU, this is a great lecture on using Postgres to do vector manipulation. I think you'll find it interesting, this lecture. And the second one is regarding DuckDb, which is a great tool to process in memory, also large data sets. And because you can start an instance only for an hour, load 400 gigabytes of data into RAM, into DuckDB, tell them, put it in Parquet somewhere, and later all of your queries will be much cheaper and more effective. Okay, now actual Go. I'm gonna give a very brief and uneducated explanation. Later you can go and learn it properly. So a Go routine, we will handle it the same as a lightweight thread, and it's managed by the Go runtime. So both of those quotes are from the Go by example website. And the nice thing from our side as developers that we don't need to handle the GIL. The GIL will not, this GIL, the GIL will not slow us down without overhead of processes. So when we use Python, in order to avoid the GIL, a GIL is something that prevents threads from the same process to run at once for Python and Ruby and interpreted languages. So here you can use something similar to a thread, but can do actually parallelize. Global interpreter lock. Okay. So on the model mental, we create a lot of threads. The Go scheduler does something, and then it just runs. Okay, we don't need to take to think too much. Now, Go channel. So as like a mental model, as I see a Go channel, it is basically a FIFO queue, which is synchronized and it's blocking on empty. So as long as it's empty, any one of the readers is blocked and is waiting. So it's easy to reason about, right? I can run sync code that waits on something. Once somebody will push data inside, the first in, first out, someone will take it and process it, okay? So I'm writing sync code on both sides. The producer writes is a sync code, and the consumer is a sync code. And I have this fully managed queue in memory in the middle, okay? As a follow-up, this is a great course on Go class. It's 13 lectures, and I recommend watching it while doing something else, like the dishes, okay?
Only Go class or it's a Go class?
it's a YouTube course. Yeah, YouTube course, 13 lectures, and it's a really good lecture. It's one of the best courses I've seen. Okay, now we're gonna write code. Okay, so take the main that you've written and create your own first channel. We will call it, and it's gonna be of type int, and it's gonna have one size. We are not going to talk at all about unbuffered channels, meaning channel without the number. Okay, we're only going to do buffer channels. So make a channel of size 1 and then print its length. Okay, whoever finished, raise his hand. Barrel is number 1. Whenever you have a print, raise your hand so I know you finished. Great, and now we can push only one object, right? And once it will be empty, it's going to block. And I can create also a channel with 100, and then I can push 100, and the 101 will be blocked. Let's continue. A channel, for our consideration, is just a queue.
זה הגודל של ה-Q.
כן, זה אשכרה queue. If you do it 1, it's 1. If you do it 100, it's 100.
Maybe it's worth mentioning that channel is basically a way to communicate between threads.
Okay, so now write your first value into the channel and then print its length. And tell me when you finished. And enter another one. What does it do?
Deadlock. Fatal.
Good. Good. But what you see here is that the channel is blocked, and after some times nobody read, and then you got the error. Okay, so this is going to allow us to synchronize between different threads. Let's continue. And this deadlock is a very good tool when you have a larger application, because troubleshooting deadlocks, it's not fun. I wasted, I think, maybe netto more than a week in my life in man hours to troubleshoot it. And this is a good one. There's also an additional flag that you can pass, which helps you even further find race conditions. So this is nice to have it built in the language. Good. Now we're going to do, before the second push, we're gonna read. How do we read? We do the same, that on the right side is the channel, right? We don't push to the channel, we read from the channel. And this notation, this weird notation, it says that define this variable with the type of whatever comes from the right side, okay? And let me know when you finished. Okay, so now we are writing to a channel, read from the channel, and then we can write again, okay? Okay, now we're going to write our first Go routine. So what you are going to do, you're going to change the main method to look like this, to go push 0 and pass the channel inside, okay? On both of the places that we did a push, you change it to go push. And then you're gonna use the GitHub, the Copilot. So you have the entire prompt in the repo under prompt / insert text. So use it and you will write your own push method. This is an AI company, you must use AI. Must. You cannot write alone. So let me know once you have a working code. Okay. So this is an example of a method that does the push. First we print some information, then we go to sleep, and then we do the push. The points that we want to, that I want you to notice from the prints is that this code is completely async, right? He might only run in a few hours if there will be no free CPU or thread. So you run this async code and then you block. And the beauty of this notation is that you will know for sure that this line will only run once this push happens, right? Because this is a blocking operation. So you can reason about it. You know that you will never go down this line until one of the workers will do its push, okay? But this line is already completely running in concurrency with this operation. So you will never know what happened first, this print or this print, right? You will not know, but you will always know that everything above the push happened before here. Okay, so now how can we sync n workers? Sometimes we want to run, like to do a fan out, doing 100 operations, waiting for all of them to finish, and then and only then continuing. So what we are going to do is we are going to push 999, what's that? Okay, so you're going to take the first push and you're gonna click on this thing and do modify using Copilot, okay? And use the prompt / for loop worker. It will surround this thing with a for loop and push the index. So do it, run it, and let me know when you finish. Only the first push, yes. Surround the first push only, then do modify. Okay. So what do we see here? We see that we have a for loop, an old school for loop, right? And we take the index, we put it into the push. Now, they are all going to run in concurrency, right? And it's gonna be blocked. The first one that writes to the channel, the main thread is gonna get freed and continue running. And you will also see that you don't have all of the prints of finished, right? You will not see the ended index for all of the workers. This is because the main thread does not wait for all the go routines, okay? You can start whatever go routines you want in the background. The second that the main thread is finished, your program is done, okay? So if you want to wait for all of the workers, you must wait for all of the workers. So this is okay, so do this code edit, and now you know that you have 5 workers, so you're going to wait 5 times, right? You must know ahead the number of workers that you're going to wait. Let me know when you finish, and then it's working. Huh? We need text? No, not this time you write the code. Yeah, this is gonna be first. It's number 1. If you move the last go push from the program. So what we did now, we started 5 operations and we waited for them, okay? So usually inside the Go code base, you will see it called as the done channel, okay? The done channel. You will create 2 channels. One of them will be the done channel, and then you will have the actual data channel, and you will start 5 times, and you will pass both of the channel inside, and you will put the actual data into one channel, and you will put the finish into the second channel. This is only for convenience, okay? The second method is completely valid. But sometimes when you want to know when stuff finished, you will use a done channel, which is just a channel, okay? Nothing special. Okay, so now we are moving to actually doing the S3 implementation. So on high level, what we would like to do is have a single worker listing the files. There is no way to do parallel listing properly. And then you will have many go routines that does the read and a single worker that will run write to disk, okay? This is very similar to map and reduce, right? It's all the similar, only that you're running on one computer. Now, on a real world, if it fits in memory size, I will do it by writing to a RAM disk, which is a disk, which is actually in the memory, but it looks and behaves like a disk, or IO bytes object, or whatever you call it. And maybe if I don't care about the super performance, I will just write it to local disk. I prefer to write to local disk whenever I can. And then I use the S3 CLI just to upload the files, right? I wouldn't need to write this in Go. I just use Go to create the local files. But if it's bigger than memory, let's say I have 1.5 terabytes. So 1.5 terabyte RAM, it's a problem, right? 500, no problem, $2 an hour, okay? But once the RAM goes up, the price goes very, very up. So you can do streaming. Instead of writing into disk, you will do streaming directly, and you would like to chunk it to files. So usually you would like to your end files to be around 150 megabytes. It depends on the client. Okay, so how we're going to do it in Go? So we will have a Go routine, which is called a list, and it's going to write the results to a list channel, okay? And then we will have a Go routine called read. It's going to take the keys from the list channel, and it's going to write to the content channel. And at the end, we're going to have a single write Go routine that will take all of the actual content and will write them to disk, okay? So this is how channels help us break the code into different sections that it's easier to reason about, right? If we were a bit in a different approach, we can do it in different programs and use pipes, right? Linux pipes can serve the same ability, but here, for me at least, the code is much more readable. So having like a bash script running different command line tools and talking with pipes, it gets scary very fast. So let's do the single list into list, okay? Take all of your function main, and it should look like this. Write the function main by hand, and then mark it and put the prompt inside, okay?
So remove everything we done or new file?
Delete all of your, delete your current main and write a new one, which look exactly like this, and then write the prompt from here. When you run it, it will not work because you'll need S3 credentials, and I didn't have time to create a S3 account. Okay, so now you will going to see a lot of red arrows that you're going to see a lot of red arrows that you have missing dependencies. So open the terminal and write go more tidy. Okay?
The terminal inside the...
Yeah, but first go over the prompt and see it's only got you packages from /AWS. Okay?
Yeah.
See, it's all of them is GitHub /AWS, not I am an evil guy that inject my code. Okay?
GitHub.
So God more tidy goes over all of your package, find all of the imports and add them as dependencies. Okay, this is different from pip file, for example, because at pip file you need to tell them your dependency and then you use it. Go more tidy does it directly by analyzing the code. Listen up, it doesn't matter if it works because we have limited time, so flow with me, okay? After we did the go more tightly, by theory, it should get all of your packages and update the VS Code. When it doesn't work, later call me and we will sit and make it work, okay? Now let's go over the code, understand what it does. First, it does a defer clause to this channel. A defer clause, it says that once this worker is going to finish, it's going to close the channel. By closing the channel, it is a way of communication outside that nobody will ever put new values into the list. So later on the code, somebody can do a switch case or to check if this channel is open. Then you can know definitely that this function finished. Okay, this is another option to having a done channel. Okay, if you know that you do something and you finish, you can close the channel. If we would have run more than one worker that does the list, we could not have used this method because a different go routine would have closed a channel that we use. Okay.
It runs at the end of the function?
Yeah. And if you do several defers, it's gonna be, I don't remember if FIFO or LIFO, but one of them at the end of the function in the same order. Okay. Which sometimes is important because you defer stuff with dependencies. Okay, so here it's going to load the default configuration. This is important because we want to take the role of the user based on the AWS credentials chain. So on EC2, will take its role, and your computer, it will use your own end variables. And then we're creating a client from the config. We set the parameters for the list, which is the bucket and the prefix. We passed it as params. And then we do paginator. So a paginator is a helper method to do a for loop. Okay? If you will not tell the Copilot to use a paginator, it will use a plain list object, and it will take the token from the response and pass it again. It's a bit uglier, and this is very straightforward, just to use the paginator. So while it returns true, you take the actual content, which is a page. The page should hold 1000 files each time by default at max. And then for each one of the files, it push the key into the list. Now you see this kochavit, asterisk. It needs this asterisk because this object is an actual struct, an object, and it sits not directly. You need to go to the somewhere the heap or something to get it. So this is the asterisk. You go to the memory location, and then you bring the key from there. And I might just give a very bad explanation on it.
I have the close function at the end of the function without the default.
It's also possible because you do the paginator it's a sync method. So it will have the same, it will have the same meaning. It is like Go style to put the defer on top. Why? Because מה?
כמו כזה,
אתה מזכיר פיינלי, לא? זה לא כמו פיינלי?
יש קולקטור כזה, לא? שהפונקשן,
כן.
דיפר, כאילו.
כן, the main good thing about defer is that if someone later return a return in the middle of the function, let's say on exception, you will always close it, right? If you have a close at the end, you need to do try catch the entire way to close it.
אז זה עובד כמו פיינלי בעצם.
כן. Okay, the second part, which is list to many read to content. Don't do the prompt. I will just go over the result because we ran out of time. So what we are going to do, we're going to add this part, which is after we did the list. We want to start 100 workers to do the actual reading, okay? So you will write this by hand, and then you will put a prompt inside. And the prompt will say, I want to use the official AWS SDK to read the S3 file as a string, must be a string, and push the result into the read. And it's also going to do it in an infinite for loop. And it's a long function, so I'm going to go over it in two parts, okay? The first one is the same that we saw, right? We generate a client. And then we have a for loop. And the for loop is going to read forever from this list, okay? When is it going to stop? When the list returns not okay. The list only returns not okay when the channel is closed. Okay, this is the communication that we said before, okay? So once the channel is closed, it's going to return not okay, and you're going to break out of this infinite for loop. Okay, this is a very common pattern that you will see in many Go code base. Something is generating data, and when you finish, you will close the channel. And you might have different pieces of code doing different stuff, listening on this channel, and then you communicate. I finished by closing the channel. Another way to do it is by using a switch case that I will not explain here, but you can see it in the course. Okay, the second part is again generating a parameters, this time for read operation. Then you do the actual read. And now we're having, it's going to return us bytes. So we need to do some ugly real language, not Python stuff to generate a buffer and then to write to a buffer. We don't care. At the end, we're going to have a string. And we're going to write this string into the read channel, okay? So usually in Python, we'll skip this entire part, but okay. we did something, and then we're going to write the string directly to the read channel. Now, by the way, I prefer to have the channels with types like the actual data structure. So here I will create a channel of a type of S3 object, okay? But it will make the example a bit more complex, so I didn't do it. But having a string breaks type safety, okay? So you do prefer whenever it makes sense to have the channel on the concrete data type, but be wary of memory usage, okay? If it's a very big struct, maybe you do want to just take one parameter outside and use a native type. Okay, now you have the final step, which is...
אז הצ'אנל כאילו עוזר לנו שהרייט תהיה אסינכרוני. כאילו, אני לא הצלחתי להבין איפה אתה אומר, ומה הוא עוזר במקרה הזה.
So in this case, it helps because this for loop, if you run it 1,000 times on a big CPU, it's gonna utilize really all of the cores, and you will not have concurrency issue. We didn't see any semaphore, any mutex, any locking mechanism. You didn't need to open a file with exclusive lock to make sure that nobody writes to your file, okay? So this is the big benefit. This is very simple code to really run concurrency, okay? And if you want no parallel, you just run with one worker. You want huge parallel, you do it with 10,000 and start a big machine.
It will utilize the parallelism, like the workers automatically. You don't need to define it.
You mean the max workers?
For example, we have now place with 2 workers.
Yeah.
I don't need to define now like the parallelism in the code.
You
Automatically does it
define how much workers you start, right?
in the I.
Yeah.
This number?
Yeah. How much workers do you want?
No, I can define like 4 with how much workers I open the program with.
So there's different stuff. Here you programmatically start how many go routines you would like, okay? You have some environment variables that says what is the maximum concurrency you will have, right? But it also, this value derived from the number of cores that you have if you don't explicitly set it, right? And the go routines are cheap. In my example, I started 10,000 go routines and just started a big machine. It was okay, right? Yeah. So the big benefit is just simplicity. Now, the third part is homework, right? So you can do it. It's write a prompt. It will write it for you. It's not complex because you're gonna have a single writer again. Okay. So you only do go func once. You don't need a for loop, and write it to this, and then come to me and I will do you code review if you want. Okay, questions.
אנחנו משתמשים בזה?
For one-off task, I use it because the S3 is big and I need it. For running operations, it depends. I mean, for a web server, usually the Python can do a good enough job, especially because Django 4.2 has async built in. So you can do an async view and you don't need fast API and all this bullshit, okay? It's built in already in Django. But if there's like a critical path that is very either CPU bound or IO bound and you need to parallelize, then it's a good option. You can also call Go from the Python, right? You can have the entire endpoint in Python, just call the Go.
Also, its performance is much better than Python.
Yeah, again, it depends. If you're IO blocked, who cares, right? Because you're waiting on external. But if your CPU blocked, it's very, yes, it can do a large difference. So, thank you.